In this video, we'll be looking at lesson 1.7, factoring, and we'll be using the AC method for when A does not equal 1. Our essential question will be, how do I factor a quadratic when A does not equal 1? Now, the first question I feel like that comes to mind is, where is this letter A and this letter C even coming from? So the first thing we'll need to kind of look at is our quadratic in standard form. So if I have a quadratic in standard form, it'll be something like this. I'll have a x squared plus b x plus c. So standard form is that kind of where we have our highest exponent, the 2, coming first, and then x without an exponent or an exponent of 1 in the middle, and then our constant term coming last. So for example, say I'm looking at 3x squared plus 4x minus 6, we can say a equals 3, b equals 4, and we got to make sure we hold on to our negatives, so c would equal negative 6. So that's how we can identify our different values just by looking at the equation in standard form. So we're going to really need to be able to identify these values so we can use them in today's lesson. So there's really like two main things that we're doing today. We're really going to be leaning on what we did yesterday, or in the previous lesson. We are going to use the AC method to kind of do this reverse math that's going to feel a little weird, but then it'll all make sense once we kind of come to the conclusion of the problem. So we'll have really two steps, but the second step is both steps are a little involved. So step 1 will be to use the A C method to split, and this is where it's going to get a little weird, to split the B term, or the B value, into two terms. Okay. It's a lot to unpack right there, but you'll see, and it's kind of like this puzzle type of game that we're going to play. So if we get into a mindset of, this is a puzzle I'm trying to solve, it's kind of more like a game, a brain teaser, might make it a little bit more digestible. So we're going to call this the A AC method. And the reason why it's called the AC method is because I'm going to take my A value and my C value, and notice how I've been writing it the whole time A times C, and that's exactly what I'm going to do. So I'm going to create this X right here. And this part right here isn't like some kind of mathematical rigor that you'll find in, you know, textbooks or something. It's really like an organizational type of piece or a side work type of piece. So I'm going to take my A times my C, and I'm going to kind of place it right here. So let's use an example. I need some more space. Sorry about this. So here's our example that we're going to be working with. I will have 2x squared, so 2x squared plus 19x plus, and my C value is 24. So in the AC method, I'm going to take my A and multiply it by my C. So let's draw our big X for organization. This is where we do our work and our thinking. So in this zone right here, I'm going to go 2 times my A times my C. So I'm going to put 2 times 24, and that's going to equal 48. So I'm putting A times C right here. 2 times 24 is right there. And in the bottom, I'm going to put my B value. And my B value is 19. So we did A times C in the top, and we did our B value right there. Now, how I fill in these two side zones is I need to find two numbers that when I multiply equal 48, and when I add equal 19. That's kind of the challenge right now. Is how do I go through all the kind of like multiples of 48 and find the ones that when I add together equal 19. So we can start kind of thinking, well, we can do 6 times 8 is 48, but 6 plus 8 is not 19. So I can't use 6 and 8. We could try 4 and 12. 4 times 12 is 48, but 4 plus 12 equals 16. So that is not 19. So you go through all the different kind of multiples of 48, and what we'll find is that we end up with these two values, 16 and 3. 16 times 3 is 48, and 16 plus 3 is 19. Now, so we use the AC method, and now we're going to split our B term. We're going to split that 19 using these two numbers. So this is how that will look. I'll have my 2x squared It's copying the problem again, plus 19x plus 24. And here's where the magic kind of happens. The 2x squared will come straight down. I'm not doing anything with it, so I'm going to leave it the same. Plus, now I'm splitting the b term into these two values. So I'll end up with a plus 16x plus 3x. And then I can bring that plus 24 right down. So this is kind of the weird part because we're not used to just randomly breaking up terms into more terms. It's like, why would I make it more complicated? But now we can lean on yesterday or on the previous lesson, and we can actually use our factor by grouping to factor this. So all we've done is split this up. So there's my 16 coming from right here, and there's my 3 coming from right there. And now we're ready to factor by grouping. So all I'm going to do right now is copy my problem. So my final step, step 2, is factor by grouping. So I'm going to take, I'm just going to copy the problem again and put my parentheses around it, and then we'll keep moving. So I'm going to have my 2x squared plus 16x plus 3x plus 24. Now we throw up our parentheses, and we're just going through this grouping factoring process. What can I factor out of 2x squared and 16x? Well, they both have a 2 that I can factor out, and they both have an x. So I can say 2x times, when I factor out, I'm dividing, so that's an x plus 8, plus, and I can factor 3 out of both of those, and I'm left with an x plus 8. Now they both have x plus 8, so I can pull that out, and I have left 2x plus 3. So the most important piece is this. This is the new piece right here. This A.C Method, which is kind of confusing right out the gate, but it'll the more we practice, like all things in life, the more it'll make sense. So let's do another example. We'll do it on the back. So I'm going to look at this one, where I have 3x, let's give it some room, 3x squared plus 17x plus 10. And I'm going to label things A, B, and C. A is 3, B is 17, C is 10. Now I can come over here. I'm going to use my AC method. If I do A times C up in this box, I'm going to go 3 times 10. A is 3, C is 10. 3 times 10 is 30. So I put that in that zone right there. In my bottom zone, I will put the 17. And the idea is what can multiply to 30 and add to 17. So we rack our brains, we're thinking, and I end up with 15 and 2. So what I'm doing is I'm splitting my b term up into two terms, 15x and 2x. 15x plus 2x will equal 17x. So I'm not changing the value or the outcome, I'm just doing this weird kind of splitting up thing. So I have 3x squared plus, here's where my splitting happens, 15x, sorry about that, 15x plus 2x, and then my plus 10 comes back down. And now I can do my factor by grouping. So we just do this part to help us split it up so we can go to the factor by grouping. So let's copy the problem again. So when we look back at this, we know what happened. Now I'm putting up my parentheses, and I'm just finding what's common to the first section, what's common to the second section, factor it out, and then finish the problem. So I can pull a 3x out of both of these, factor out of 3x from both of these. That leaves me with an x when I factor out 3x. And when I factor out 3x from 15x, I'm left with a 5. Bring my plus sign down, and now I can factor a 2 out of both of these. 2x divided by 2 is x. 10 divided by 2 is 5. And now I have my common factoring term. So I have x plus 5, pulling that, factoring that out, times 3x plus 2. And then we're done. So the most challenging part about this is really, well, there's a lot of challenging parts. But I find that it's sometimes difficult to kind of find these numbers, like really racking your brain on what two numbers can multiply to a number and at the same time add to a different number. So 15 times 2 is 30, 15 plus 2 is 17. Now I do want to show a special case. So this is our special case. And we're going to look at this example right here. So we're going to use the same process. I'm going to go A, B, C. So I have my A equals 5, my B equals -3, and my C equals 4. We'll draw our big giant X. And remember up top we're doing A times C, and the bottom we're putting our B value. So A times C is 20, and then my B value is -3. So I need two numbers that can multiply to 20 and add to -3. So we're racking our brains. We're really thinking about this. We can use two negative numbers if we want, and we should probably be thinking in that direction if I have to add to get to -3. And so I'm really thinking, and I'm trying 5 times 4 is 20, but 5 plus 4 is not -3. I can use two negative numbers. -2 times -10 is 20, but -2 plus -10 is going to be -12, so that's not going to work. So you try all these numbers, you try all these combinations, and you're like, nothing works. Well, what ends up happening is this cannot be factored, so nothing works, meaning this quadratic cannot be factored, so we call it prime. So it's a prime quadratic. And so if nothing works, your answer will be prime. And that's how you would answer that. So, but don't like immediately jump to that. Really, you really have to go through quite a few of them. Typically, like I'll only put one prime on any kind of like homework or quiz or test. So if you're thinking like, oh look, they're all prime, I'd go back and check a lot of your work to make sure that that's the case. So that's it for this lesson, factoring quadratics using the AC method. Thank you for watching this video, and I hope you have a great rest of your day.